Hello, hello. This is what we did on Wednesday. So, don't you just love it when you record a whole video and there was no sound being recorded? Yep, that's what I did. So, let's just start off. I backtracked a little bit because nothing was recorded microphone sound-wise. So I start off with a free body diagram for this crate that is being pulled at a force of 185 newtons at an angle of 25 with a horizontal. The mu is given to us, so I can assume there's friction. And also it wants us to find acceleration. So the problem is that we're given two types of acceleration to deal with. I know it's not going to be in the y direction. This is the reason why. So this crate is moved in the x direction. It is not moved up and down. So since it is not moved up and down, then I can safely assume that acceleration is going to be equal to 0, which results in everything, sum of forces in the y direction equal to 0. So now I'm going to take my forces in the x direction, 1, 2, and I'm going to plug it in over here. So whenever I do that, I have f of a cosine theta minus force of friction, because it's going opposite the direction of motion, equal to ma. And I can expand force of friction as mu times force normal. That is the given equation for force of friction, equals to ma. And then I can just drag down fa cosine theta. So from here, all I have to do is find my forces for the y direction. I just wanted to change that color. So for the y direction, there's 3 of them. 1, 2, 3. And these 3 are going to be force normal plus fa sine theta minus f of g, which will become mg. Okay, so this will become mass times gravity. Okay, so from here, I want to solve for acceleration once again. So that means I need to know every single other value in here. So I know my force applied, 185. I know my cosine theta, theta, which is given to me. Mu is given to me. Force normal isn't really given to me, but I can solve for it using this side. So on the y direction side, I can solve for force normal by moving all of these terms to the other side. So I'm going to first rearrange a little bit. So mg is going to be positive, and then fa sine theta is going to be negative. And this is really because fa sine theta was originally positive and f of g was negative. So I just made them opposite of each other. So all of this, I'm going to plug it in right over here for f of n. So if I do that, then I will have, I'm just gonna write mg minus f of a sine theta. I'm gonna put all of this in parentheses, gonna zoom in too. I'm gonna carry everything down. ma f of a cosine theta. Okay, so from here, really close. From here, I need to solve for a, so I'm gonna solve for m on both, divide by m on both sides. Acceleration will end up being, just gonna rewrite everything, f of a cosine theta minus mu mg f of a sine theta. Okay, so all of these values, I'm just gonna plug in the numbers. So we got 185 cosine of 25 minus 0.45 times 35, which is the mass, times gravity, which is 10, minus force applied, which is 185, sine of 25, all over my mass, which is 35. So from here, my answer should be 1. Well, if I put this into the calculator, then it'll be 1.3 even though my given answer was supposed to be 1.39, but you know, it's really because I used 10 for gravity instead of 9.81. So if we were to interpret this, whenever this block is being pulled here, then that means the acceleration is going to be 1.30 for the acceleration, and acceleration will depend on the amount of force that is being applied. It will also depend on how much friction there is given in this part, and also acceleration has an inverse relationship with mass. So the more mass there is, the less acceleration there is, because mass is on the bottom while acceleration's on top. Granted, there is mass over here, but you know, that's always being just subtracted from here, so usually the mass will be taken away from this force. So the main thing is that mass is mainly on the bottom. It's kind of taken over the bottom. So if mass increases, then acceleration will decrease. Let's go on to the next one. So we have a crate that is weighing 319 newtons. So right off the bat, they give you weight, which is force of gravity, shoved along the floor with a force of 485 with an angle of 35 below the horizontal. If the mu is 0.57, how long will it take to move it from 4 meters starting from rest? So since they're asking us for time, then we need to use our UAM equations, and every UAM equation asks us to find acceleration. So guess what? We're finding for acceleration once again. So I'm going to draw my free body diagram. So with this free body diagram, we got force of gravity, force normal, regular, and then we have, I'm going to draw this guy's pushing of the block 35 degrees below the horizontal, and then I'm going to break those forces into its components. Okay, so I'm going to draw little arrows, and that force applied is going to be F of A, and it's going to be equal to 485 newtons. So I'm just going to give this a variable. Force applied is going to be multiplied by sine theta, and force applied is going to be, let me move that part over here so that it can tag onto this diagonal. So F of A cosine theta is going to be the horizontal component. So now I'm going to take all of that and I'm going to copy it, copy, paste. There we go. Oh, that did not go well. Oh yeah, it did not go well because we forgot about friction. So force of friction over here. All right, now let's copy and paste. Okay. All right, here we got going on. We have the free body diagram. So from here, same deal as before. We just have to use the forces in the x direction equal to mass times acceleration. And then the forces in the y direction is equal to mass times acceleration in the y direction. So same deal as before, this block is being pushed in this direction to the right. It is not being pushed up and down, even though there is a diagonal force being applied. Overall, the box is traveling to the right. So forces in the y direction is going to be equal to 0 because acceleration in the y direction is equal to 0. So I know that I need to find acceleration so that I can use my UAM equations. So I'm going to find A of x. So my forces in the x direction, force of friction, force applied. Y direction, force normal, f of g, fa sine theta. So let's do that. So force applied cosine theta is positive minus force of friction is equal to ma. Force in the y direction is going to be force normal minus force applied sine theta because the arrow is going down, and then likewise with force of gravity, also negative. Okay, so from here let's just expand our equation. So when we expand our equation, we have f of a cosine theta minus force of friction, which is mu times force normal, is equal to ma. And then we also have f of n minus f of a sine theta minus f of g, which becomes mg, equal to 0. So I'm going to solve for acceleration, but I need to make sure I have everything. So I have force applied, I have theta, mu, I have mass, but I don't have force normal, so I need to solve for force normal. So first I'm going to solve for acceleration on the x direction. Kabam, that's pretty easy. And then I'm going to solve for force normal on the y direction. So I'm just going to add f of a sine theta and then add mg sine theta to both sides. So whenever I do that, so I'm going to copy, paste. Okay, so I'm going to do that to both sides. So whenever I do that, I will end up getting, there we go. There we go. F of a cos, and then I'm going to take all this. Oh, that's messy. It's fine. And put it right in there. And then my equation for acceleration will end up being f of a cosine theta minus mu times f of a sine theta plus mass times gravity. And this is all going to be over mass. So I also have everything in my y direction, like all my unknowns as well. So I'm just going to plug it in. So whenever I plug it in, I should get this. So it's going to be 485 cosine of 35 minus mu, which is 0.57, multiplied by 485, the force applied, sine of 35, plus my force of gravity. So we could just separate it into its mass and gravity, but I also know that my weight is already given to me. So f of g is equal to mg. So I actually wasted a little bit of time by bringing out mg. So I'm just going to say that that is 319 newtons. Okay, so 319. And then I'm going to insert mass. So I guess I didn't waste too much time, but f of g is going to be equal to 319. Well, we also know that f of g is equal to mg. Just going to go off onto a tangent, off to the side. So 315 can go in place for the weight. My mass is my unknown. My gravity is 10. So if I want to solve for mass, I divide by 10 on both sides, and then mass should end up being 31.5 kilograms. Okay, so from here, take that, put that in place of mass. So that's going to be 31.9 kilograms, and then my answer should be 1.78 meters per second squared. Okay, so that's my acceleration. So the question isn't asking for acceleration though, it's asking for the time. So now I'm going to take all of this and I'm going to use my UAM to find time. So of course we are going to need to set up our toolbox. So x, x, v, v, a, t. Acceleration is already given to me, so I have 1.78 meters per second squared. I'm gonna zoom in on this. So I need to find time, the initial, final. Okay, so I need to find time. It's given to me over here that my initial velocity is 0. It moves 4 meters, and yeah, so that's the information that it gives us. So it moves from 0 to 4 meters, starts from 0, and they don't give us final velocity. So now we can use our equation that has time in it, but it also doesn't have final velocity because we do not know those values. So I know that my initial velocity is going to end up being 0. So I can use this equation. I'm going to solve for this algebraically. So whenever you solve for this algebraically, you can multiply by 2 on both sides. So whenever you do that, these two cancel out. And then at squared is equal to 2 times change in x. So divide by a on both sides. And then it'll end up being 2 times change in x over a. Put a little square root house top on there. And then t should equal 2 times distance over a. So we're going to do 2 times distance, which is 4, over 1.78. So whenever I do all that, I put it into the calculator. My value should end up being time is equal to 2.12 seconds. Okay, so it's going to take that much time for the box to move 4 meters. Okay, with the applied force. All right, on to the next video.